All right, now let's begin with question 5b, part 1. So you can see all 3 questions are here, but I've chosen to split them up into 3 separate videos, just so that the video doesn't get too long and it's easier to focus. So let's begin. They say to me, you are given a water solution and it contains 1.7 kilograms of nitric acid, that's HNO3, for every 1 kilogram of water. So for every 1 kilogram of water I have about 2 kilograms of nitric acid. And it has an SG, or specific gravity, of 1.832 at 20 degrees Celsius. By now you should be a master at converting SG to density, so you know that this means it's got a density of 1,382 kilograms per cubic meter. So it's a little bit heavier than water. And they want us to express the composition of this acid in the following ways. Firstly, give us the mass percentage of nitric acid. So how I'm going to begin this is, I'm just going to rewrite the ratio, okay? I know that for every 1 kilogram of water, I've got 1.704 kilograms of nitric acid. Okay, let me just put this in a box. And the next thing I'm going to ask myself is, how do you calculate mass percentage? So you'll already know this, okay, from our previous tutorials. Mass percentage is equal to the mass of compound 1 divided by the total mass of the solution. And then you're going to multiply that by 100%. So you can go back to our mole mass fraction examples, but this is the equation from there, okay? If you would like to see more examples, just go a little bit back. I don't think it's too far away. All right. So they want to know, what is the mass percentage of nitric acid? So if I had to look at this, I can say, all right, my mass percentage of nitric acid is equal to the mass of nitric acid divided by the total mass, and it's times 100%. So if we look at this mass ratio above, I know that I've got 1.704 kilograms of nitric acid. Okay, so I've got 1.704 kilograms of nitric acid. And then if I've got 1.704 kilograms of nitric acid, then I must have 1 kilogram of water. Okay, but it's the total mass, right? So I need to add on the mass of the nitric acid as well, and multiply that by 100%. And do you agree that is the total mass of the solution? Because what I'm essentially saying to you is, okay, if this makes sense, you can skip this, but I just want to make sure I explain it properly in case anyone is confused. So this is your nitric acid, and this is your water. So what I'm saying is, for every 1.7 kilograms of nitric acid I will have 1 kilogram of water. And then the total mass becomes 1.7 kilograms plus the 1 kilogram, which is 2,704 kilograms for the total solution mass. All right, so if you put that into your calculator, you end up with 0.63 times 100%, which is equal to 63%. All right, very simple, very straightforward. Let's move on to part 2. All right, now let's have a look at question 5b, part 2. In the first part of the question, we said that the mass percentage of nitric acid in this solution is 63.01%. So I want to ensure that you understand what this means. If someone tells you that 63.01% is the mass percent, it means that if you take the solution, 63% of that solution's mass is going to be brought about by just the nitric acid. And remember that your mass percentage is how much of nitric acid you have over the total solution's mass. So I can say 63% of the mass of the solution is contributed to by the fact that there is nitric acid in this liquid. Okay, So the second part of the question says to you, calculate or express the composition as pounds of nitric acid per cubic foot of solution. So that's pound mass per cubic foot, okay, which you agree looks a lot like a density unit. So a good place to start here would be starting with the SG, calculating the density. And once you've got the density, you can then say how much of that density is nitric acid. So I'm going to put down part 2 over here, and let's begin. So I know that SG is equal to 1.382 at 20 degrees C. Remember that SG, and you should be a master at this by now, SG is equal to the density of your nitric acid solution divided by the density of water at 20 degrees Celsius. And so we end up with the density of nitric acid being equal to 1.382 multiplied by 1,000 kilograms per cubic meter, which is equal to 1382 kilograms per cubic meter. All right, so I've got the density. I'm happy with that. Let's put it in a box. Okay. Now that I've got the density, they want me to express pound mass, but not pound mass of solution. Remember, this is kilograms of solution per cubic meter of solution. They want mass of nitric acid. So what I'm going to do is say, all right, I can express the composition in the following way. I know that I've got 1382 kilograms of solution for every 1 cubic meter of solution. Okay? And I'm going to say, therefore, I have 63.01% of this 1382 is going to be nitric acid. And then again, divide that by 1 cubic meter of solution. And that is going to equal to, I don't like this arrow being here, so I'm just going to draw a line, okay? So I'm going to say density is equal to this, and then I can say, therefore, 63.01% of 1382 kilograms is what my mass of nitric acid is. And if you put that into your calculator, you should end up with 870.80 kilograms. And this is kilograms of nitric acid because it's 63% of the solution's mass per 1 cubic meter of solution. So we've got an answer, but the question says pounds of NO3 or pounds of nitric acid per cubic foot of solution. So I've got one more conversion to go, but by now you are a ladder method ninja. So that's 870.80 kilograms per 1 cubic meter. All right, let's go. I'm going to put kilograms at the bottom because I want kilograms at the bottom to cancel with kilograms at the top. And I want to convert it into pound masses. I know that 1 pound mass is around half a kg or 0.4536 kilograms. Next, I'm going to write cubic meters at the top because I want cubic meters at the top to cancel with cubic meters at the bottom. And I want to convert it into feet. Okay, I know that before I put this cubic meter down, I know that 1 foot is around 30 centimeters or 0.3048 meters. Because I want to cancel cubic meters, I'm going to cube it. And whatever you do at the top of the ladder, you must do at the bottom of the ladder. So you put in all of these conversions, and you should end up with 54.36 pound masses of nitric acid per cubic foot of solution. And this is your final answer. But as always, you know that I like to do a sanity check or a double check just to see if I'm on the right track. So watch this. 870.80 kilograms per cubic meter was my solution density. I know, and let me just do this on the side, right? I know that if I've got 1,000 kilograms per cubic meter, that is the density of water. And you should already know this, that the density of water in the imperial system in pound mass per cubic foot is 62.4 pound masses per cubic foot. Okay, so if I've got a number now like 870 kilograms per cubic meter, then do you agree that my resulting answer should be less than 62.4 pound mass per cubic foot? And if we go across to my answer, it is indeed a little bit less than 62, it's 54. And so I don't know that the answer is correct, but I know that the chances of my answer being correct is a bit higher than 0. All right, so that's done. Thank you for watching. Let's move on to part 3 of the question.